Okay guys, welcome back. We are going to do Chapter 5, Section 6, Half-Angle Identities. This video is probably going to be a little noisier and the setup is a little weird because we have moved home. It's spring of 2020. Fort Worth is on a shelter-in-place order for the pandemic, and I am figuring out how to do online classes from the comfort of my home office. I've got my fancy cardboard box stand for my Surface so we can do these guided notes. I've already messed up once and had to start the video over, so we've got a head start here. When we're doing half-angle identities, recognize that we are focusing on the relationship between the two arguments. We don't actually have to say half x because I'm looking at the relationship between the two. I know that x is half of 2x. That's true. What is also true would be that 2x is half of 4x, or that half x is half of x. So I'm not focusing on how I'm writing the argument. I'm focusing on the fact that I have two arguments and one is half of the other. Okay, we are going to derive our first half-angle identity. We're not going to derive the rest, just the first. And when we derive this first half-angle identity, we're going to start with a double-angle identity. The double-angle identity that I choose to start with is cosine 2x. You should have your identity sheet so that you can go back and you can look at the double-angle identities. We're going to do cosine 2x. We've got three different cosine double-angle identities to choose from. We're going to be using this one. We're going to start with this cosine double angle identity and to use it to derive our sine half angle identity. Okay, so here we go. We're going to start with that cosine double angle. Cosine of 2x is equal to 1 minus 2 sine square x. Now, I am going to rearrange this so that I solve for sine square x. When I solve for sine square x, I'm going to move this 2 sine square x to the right so that I have 2 sine square x equals, and then I move my cosine 2x to the left, so 1 minus cosine of 2x. Well, right here, I see that I have two arguments. One is x, one is 2x. X is half of 2x, so I have my double angle situation set up. All right, solving for sine of x, I'm going to divide both sides by 2. And then to finish solving for, let's go ahead and just rewrite it. Let's say sine square x equals 1 minus cosine of 2x over 2. And then to solve for x, sine of x instead of sine square, I need to take the square root of both sides. When I take the square root, I consider that that variable could have started out positive or negative, so I do plus or minus the square root of. And so therefore, dot, dot, dot in a triangle means therefore, sine of x, I've solved for sine x, is equal to plus or minus the square root of 1 minus cosine of the double angle divided by 2. Again, x is half of 2x. If I wanted to rewrite that in those half angle terms, I could write this sine of x as sine of x half x, is equal to plus or minus the square root of 1 minus, well, instead of 2x, x is half of 2x, but half x is half of x. 1 minus cosine x over 2. These are the same identity written in two equivalent forms. Now, if you look down in this gray box where we're putting together all of our half-angle identities, you see that we have it written as sine of a over 2, sine of a half. That is going to be equal to plus or minus the square root of, all underneath the square root, 1 minus cosine a, because my argument is a half, this needs to be a, over 2. Okay. So in the following identities, the symbol plus or minus indicates that the sign is chosen based on the function under consideration and the quadrant, not of the angle, but of the half angle. That's going to be important as we move forward through this section. Okay, so take the time to go ahead and fill in these other half angle identities. Feel free to reference your identity sheet. We only have one cosine half angle and one sine half angle. We have 3 tangent half angle identities. So cosine half angle plus or minus square root of 1 plus cosine A all over 2. Then I have those 3 tangent half angle identities. I can do plus or minus square root all underneath the square root 1 minus cosine A over 1 plus cosine A. I could do sine of A over 1 plus cosine A, or I could do 1 minus cosine A all over sine A. So those are my 3 tangent half angle options. And do keep in mind, for example, just like we did this sine half angle, showed the 2 different ways I can write it based on how I want my argument written. I can do that with each of them. For example, if I take this, instead of saying A half and A, I could say tangent of A is equal to plus or minus square root of 1 minus cosine of 2A over 1 plus cosine of 2A. This argument is still half of the argument on the right side of the identity, so it still counts as a half angle identity. Okay, let's apply those half angle identities. First thing, it says to find the exact value of sine of 22.5 degrees using the half angle identity for sine. Well, first requirement is exact value. Exact value, I'm not going to be able to find with my calculator, and this is not a special angle, but 22.5 degrees is half of a special angle. So the sine of 22.5 degrees is the same thing as the sine of half of 45 degrees, because 22.5 degrees is my argument is half of 45. This means that I can use a half angle identity. If I look at my sine half angle identity, I have it structured this way so that A in this case is 45 degrees. So I'm going to use the sine half angle identity. I'm going to fill in. The half angle is in quadrant 1. 22.5 degrees is in quadrant 1, and sine is positive in quadrant 1. So I don't have to do plus or minus. I know it's going to be positive because I know where my half angle resides. And I know from my unit circle exactly what the cosine of 45 degrees is. All right, I need to simplify that complex rational expression underneath. I'm going to simplify that by multiplying by the well-chosen 1, 2 over 2. That gives me square root of 2 minus square root 2 over 4. And 4 is a perfect square, so I can simplify that denominator. And I end up with kind of the stacked square root in my numerator all over 2. Make sure you simplify to that point, simplify completely to that point. Make sure that you keep everything underneath the radical when it needs to be so that you can pull out that denominator when you have a square, perfect square denominator. Let's look at the next one. Cosine of 15 degrees. Well, 15 degrees, I need an exact value again, so I can't just plug that into my calculator. 15 degrees is half of a special angle. It's also in quadrant 1. Cosine is positive in quadrant 1. So cosine 15 degrees, well, 15 degrees is just half of 30 degrees, so I can rewrite my argument as a half angle. And then I go look at my half angle identities. Cosine half angle, I know it's going to be positive because I'm in quadrant 1. Is going to be 1 plus cosine of 30 degrees over 2. And we know cosine value of 30 degrees is a positive square root 3 over 2. Again, I have this rational expression, complex rational expression that I need to simplify. I'm going to multiply by that well-chosen 1, 2 over 2. When I do that, my result is the big square root, 2 plus square root 3 over 4. And I can simplify my denominator. Okay, that's our basics for how to use those half angle identities. Let's do it again, but with tangent on the next page. Okay, tangent half angle. Exact value, so we're going to need to use our identities. Tangent is 75. 75 is not a special angle, but it's half of 150. Tangent of 75, 75 degrees is still in quadrant 1, so tangent is going to be positive. Tangent 75 degrees, tangent of 150, half 150. And I can use, oh, it tells me to use, never mind, excuse me. It tells me to use this particular tangent half angle identity, sine A over 1 plus cosine A. I have 3 tangent identities, half angle identities to choose from, and it wants me to use this one. No problem. All right, so sine of 150 degrees over 1 plus cosine of 150 degrees. And I'm going to use my unit circle, if I can't remember off the top of my head, to fill in the known values. I get a 1/2 in my numerator and 1 minus square root 3 over 2 in my denominator. Once again, I'm using my multiplying by a well-chosen one to simplify that complex rational expression. That gives me 1/2 times 2 is 1 over 2 minus square root 3. Now, that's pretty simple, but I've got a radical in my denominator. I can't leave that. I have to rationalize my denominator. When I have a binomial, 2 terms that I need to rationalize, I multiply by that well-chosen one, and I use the conjugate, 2 plus square root 3 over itself. Now in the numerator, I just have 1 times 2 plus square root 3. That just gives me 2 plus square root 3 in my numerator. 2 plus square root 3. My denominator, when I FOIL this, the outside and inside products are opposite, so they're going to add to 0. And I end up with 2 times 2 is 4, minus square root of 3 squared is 3. So my simplified result is just 2 plus square root 3. All right, one more time, using that same half angle identity, still in quadrant 1 with our half angle, so still positive. I am not going to show you the work. I want you to follow along with what we did previously. Oh, you know what? I take that back. I am going to show you the work, because when we rationalize, we're going to do an extra step, and it won't hurt for you to be able to see that. So, okay, here we go. Square root 2 over 2 over 1 plus square root 2 over 2, multiplying by our well-chosen, 1 in the form of 2 over 2, because I've got that complex rational. That simplifies me to square root 2 over 2 plus square root 2. Then I have to use rationalizing my denominator by multiplying by the conjugate of my denominator. In the numerator, it doesn't cancel out. I'm sorry, I've got that zoomed in so you can't see my cardboard and you can't see much there. Okay, in my numerator, nothing cancels. I just end up with 2 square root 2 minus 2. My denominator, when I FOIL this, the outside and inside products add to 0. That's the beauty of a conjugate pair. And I get 4 minus 2. So to continue simplifying, 2 square root 2 minus 2 over 2. And I can reduce each of those terms. If I need to break it apart, I can. I end up with square root 2 minus 1. Okay, let's look at example 3. Example 3 gives us information about S and asks us to find information about the half angle S half. All right. Cosine S is negative 3 over 7. And S is in quadrant 3, excuse me. It's been a long morning already. S is in quadrant 3 because it's between pi and 3 pi halves. I need to find 3 different function values for the half angle S half. Well, to find these values, to know which ones are positive, which values are negative, I need to find what quadrant the half angle would fall in. So to find the quadrant of the half angle, I need to step aside and I need to take half of each of these values in my inequality. So if I take half of each of those, I end up with pi half, S half, and half of 3 pi halves is 3 pi fourths. So my half angle is here between pi half and 3 pi fourths. Well, pi half is the same thing as 90 degrees. This means that my half angle is in quadrant 2. And in quadrant 2, x is negative and y is positive. So cosine is negative, sine is positive, and tangent is negative. That's important information to come up with before I get started. Okay, As I work through my identities, I want to make sure that when I have a choice, I want to use the givens. I might not necessarily always have a choice. But you know what? I have identities that use just cosine s, so we're good. We're set. Let's do sine of s half. Well, sine of s half, my identity tells me I do square root of 1 minus cosine s over 2. And sine is going to be positive, so I don't need to do any algebraic sign out front here. Well, cosine s is a negative 3/7. So when I plug that in, I get 1 plus 3/7 all over 2. And I need to multiply by that well-chosen 1. I assume you can hear my grandfather clock in there. I apologize if that's a distraction to you. All right, and then when we distribute that in, we get 7 plus 3 over 14. 7 plus 3 is 10. So we've got square root 10 over square root 14. And I need to rationalize that denominator. Well, to rationalize that denominator, I need to multiply by the radical that I need to move out of the denominator. So I'm going to multiply top and bottom by square root 14. So that gives me square root 140 over 14. Well, square root 140, I need to check to see if I can simplify that any at all, and simplify it if I can. Because both of these factors that I multiplied together to get 140 were even, that means they both have a factor of 2, which means that 4 is a factor of 140. If I divide 140 by 4, I find out that 4 times 35 gives me 140. Square root of 4 is 2, so that's 2 square roots of 35 over 14, which simplifies to square root 35 over 7. So that's the value of my sine half angle, of the half angle. Okay, let's go back and let's do cosine of the half angle. That's next, and it is going to be negative. So when I set up this identity, I make sure that I reflect that I know cosine of the half angle is going to be negative. Plug in what I know. Multiply by that well-chosen 1 again, so that I get a negative square root of 7 minus 3 over 14. And 7 minus 3 is 4. Well, when I split this apart, square root of 4 is 2. So I have a negative 2 over square root 14. And then I just need to rationalize, which gives me negative 2 square root 14 over 14. Simplifies to be a negative, not negative 2, sorry, and I didn't bring home my whiteout. Negative square root 14 over 7. A negative square root 14 over 7. Okay, we have one last half angle value that we are asked to find. We're asked to find tangent of the half angle. And we have a half angle tangent identity that just uses cosine. So we're going to use that one. That particular identity is square root of 1 minus cosine s over 1 plus cosine s. And we identified the fact that tangent is going to be negative for this particular half angle. So that's where we start. Our cosine of s is negative. That's why those algebraic signs look like that. Multiply by our well-chosen 1 to simplify our rational expression. All right, there we go. Okay, guys, we are going to do it one more time. I'm not going to work through all the steps on the next example. We're going to talk about what quadrant we're in, and then I'm going to give you the results and give you the opportunity to go through on your own and make sure you can get those results. Okay, I'm given cosine s is 2/3, and I see that s is in quadrant 4, but I don't care where s is. I need to know where the half angle would be. So I'm going to divide each of those by 2. So that would be 3 pi fourths, s half, and pi. Well, s half is less than pi, which puts me in quadrant 2. 3 pi fourths is in quadrant 2, so the half angle is in quadrant 2. In quadrant 2, x is negative, y is positive. So sine is positive, cosine is negative, and tangent is negative again because we are in quadrant 2 for the half angle. You are interested in what quadrant the half angle is in. All right, so sine of the half angle, when you use your identity, you discover is square root 6 over 6. It's positive. Cosine of the half angle is negative. It's going to be a negative square root 30 over 6. And then tangent of the half angle, also negative, is a negative square root 5 over 5. Okay, guys, let's look at that next example, example 4. Notice that we haven't gotten around to doing any verifying of identities yet. We will get there. Let's do this example, and then we will verify a couple of identities. Okay, this is simplifying expressions using our half angle identities. We are given the right side of the identity, and we have to figure out which one it is. So pull out your identity sheet, find your half angle identity section down here for 5, 5, and 5, 6. You have a sine half angle, you have a cosine half angle, and you have 3 tangent half angles to choose from. When I look at A, I see that I have 1 minus cosine of 8x over 2. 1 minus cosine A over 2 right there. That is a sine half angle identity. That is my sine half angle identity. So let's go ahead and write that down. Sine of half angle is plus or minus square root of 1 minus cosine A over 2. So in this case, A is 8x. So half A is going to be 8x over 2. So sine of 8x over 2, which simplifies to be sine of 4x. And that's all we have to do. We don't have to go any further than that. That is all it is asking us for. So once you have identified which half angle identity you're working with, you're pretty much there. For B, if I go back and look at my half angle identities, I see that this is a tangent half angle where A would be equal to 9B in this case. So that means tangent of A half is tangent of 9 beta over 2. That doesn't simplify. So that's all it is. On C, I identified this as a cosine half angle identity where A is 12x. So cosine of A half is cosine of half 12x or cosine of 6x. And D, that is another tangent half angle where A is 5 alpha. So for tangent of half A, where A is 5 alpha, that would be tangent of 5 alpha halves. Doesn't simplify, so we're done. All right, let's look at those identities that we need to verify. Remember, when I'm verifying identities, I'm not asking if it is an identity. It is. I just want you to show me how. My left side looks fairly simple. My right side is more complex. So I'm going to choose to verify this identity by working on the right side. So, all right, I'm going to work on this right side. I know that on the left, I've got tangent of a half angle squared. And I recognize as I think about that most of my half angle identities have this plus minus square root thing going on. So I'm anticipating that I'm going to end up with a half angle identity, and then I would just have to square it to show that it's equal to that tangent half angle squared. None of them have secant. So let's go ahead and go, they all have cosine in them. So let's go ahead and go to terms of cosine and see what we come up with. Well, secant x is 1 over cosine x, plus that would be cosine x over 1 minus 2. Over 1 over cosine x minus, and I just put that cosine x over 1 because it helps me to keep things straight. You don't have to do that. You could have just said cosine x for these terms. I've got this rational expression I need to clean up. I'm going to clean it up by multiplying by my well-chosen 1, cosine x over itself. When I distribute that cosine x to each term inside, this just cancels. Cosine x over cosine x is 1, plus that's going to be cosine square x minus 2 cosine x. You know what? That's a perfect square trinomial. It's out of order, but it is a perfect square trinomial. And in my denominator, I get 1 minus cosine square x. That doesn't look exactly like, but I know that this is a difference of squares. And if I look back at my double angle identities, I see that I've got some, 1 minus cosine A, 1 plus cosine A, 1 minus plus cosine A over 2. So I want those factors. I want to get those factors. Let's factor this out. If I think about rearranging the 3 terms here, I can rearrange that to, because I've got my 1 first here, I'm going to leave my 1 first there. I'm going to rearrange this to be 1 minus 2 cosine x plus cosine square x, and that's going to help me when I factor it next. So that's what I'm going to do next, is I'm going to factor both the numerator and the denominator. When I factor those numerators and denominators, and I'm kind of running out of room, so I've done it weird instead of going straight down. I went to the right. Now I'm going to go down from this, and I'm going to say my numerator is 1 minus cosine x times 1 minus cosine x. My denominator is 1 minus cosine x times 1 plus cosine x. That factor cancels. And I'm left with 1 minus cosine x over 1 plus cosine x. Well, you know what? That is just almost a tangent half angle. If I took this identity and squared both sides, I would get this. So I might want to go ahead and say off to the side, I might want to say, look here, I've got this tangent half angle, which is equal to plus or minus 1 square root of 1 minus cosine A over 1 plus cosine A. If I were to square both sides of that, I get tangent squared A half equals this right side. So this is the same thing as tangent square x half. And I have verified my identity. You don't have to show me this. If you get to this point and then rewrite it as this, I know that you found that link. Okay, let's look at this last identity to verify. I have 2 different ways to do this. I'm going to work the first way with you, and then I'm just going to show you the other way. This time, that left side is the more complex side. So that's the side that I'm going to work on. I'm going to work on this left side. And it tells me to square this binomial. I'm just going to do that. I'm going to square this binomial. So if I square the binomial, I square the first term. So sine square of the half angle. I multiply the 2 terms together times 2. So that gives me plus 2 sine x half cosine x half. And then I square the second term, which is a positive cosine square x half. Well, Pythagorean identity. If I rearrange this and put this together, sine square x half plus cosine square x half, and then I've got 2 sine x half cosine x half. Sine square x half plus cosine square x half is just 1. That's one of my Pythagorean identities. That's just 1. So I've got 1 plus 2 sine of x half cosine of x half. And what I want to end up with is 1 plus sine x. Does this remind you of anything? Hopefully, this reminds you of a double angle identity. If I look at my identity sheet, I see that sine of the double angle is 2 sine A cosine A. And remember what I said about comparing the arguments? 2A is twice A. So A, the argument on this right side, is half the double angle. So my sine double angle, sine of 2A equals 2 sine A cosine A, where this on the right, the argument on the right, is half the argument on the left. I can take that and say, okay, if this is the half, what is x half of? Well, it's half of x. So I've got 1 plus sine x because I apply that double angle sine identity and my identity is verified. Okay, I promised you an alternate way to do this. One of my students showed me this alternate way to do this. What they did was they took that sine x half plus cosine x half and they substituted in half angle identities and then they squared that. And when you square that, this is what you come up with, which simplifies because 1 plus 1 is 2 and negative cosine A, positive cosine A adds to 0. 2 over 2 is just 1, and then square root of 4 is 2. If I take the square root of that, I get sine A. And I have verified that identity a different way. All right.